All right, on page 4 of our notes, we talk about reading a graduated cylinder or a burette using the correct number of significant figures. So on the previous page, we talked about significant figures. This is telling us the level of precision that we're using when reading glassware. So this says when reading the volume, of liquid in glassware, always measure from the bottom of the meniscus. That's your little like curve that the water will make. You'll read from the 0 always to the bottom of the meniscus. You're always also going to estimate only one place past the point of measure.
Miss, can I put the button?
No, you cannot.
Please.
No, I just heard you on the phone to me.
Can I go get my food? Can I go get my food?
I can't let you out during the first 20 of class anyway. Someone can bring it up here for you.
I bet.
Okay. All right. Sorry for those on the video that heard the interruption. You are always estimating one place past the point of measure on a graduated cylinder or on a burette. If you're just joining us, we are on page 4 of your notes. So what I want you to note here is that you probably have them. Look and see if you do. You can keep that if you need them, but we got this last Monday or Tuesday. So we're always estimating only one place past the point of measure. The thing that I want you to note about this is that if you have 45 milliliters versus 45.0 milliliters versus 45.00 milliliters or 45.000 milliliters, volume-wise, those are all the same thing, but significant figure-wise, those are all different from each other, and it's really important that you understand when it is appropriate to use each one. So that is the concept that we are trying to learn in this section. So if we look at letter A, we already did this one together. The point that I'm trying to make here with always reading from the 0 to the bottom of the meniscus is that sometimes your equipment is going to have a 0 at the top. So a burette, for example, measures how much liquid has been dispensed, not how much liquid is actually in your burette. So your 0 is at the top, and the numbers get bigger as you go down. So that's why on this one I have 28 here, and then 29, and then 30. So as I go down, my numbers are getting bigger, which means that my 0 would be up at the top. So I'm measuring from the 0 to the bottom of the meniscus, which would be here. And so if I draw like a little dotted line there, it's between these two lines that are actually marked. The lines that are actually marked are what we call the point of measure. So if I'm halfway between 28 and 29, what would we call that first line? So halfway between 28 and 29 is what value? I think we already did these notes, didn't we? So you should have it written. Or even if you don't have it written, halfway between 28 and 29. Did you say it? 28.5. Good. Okay, it's not a trick question. So 28.5. And then as you're getting closer to 29, your numbers are going to get bigger. So it's going to be 28.5, 28.6, 28.7. This is 28.8. And the next one would be 28.9. And it looks like the bottom of my meniscus is between the line for 28.8 and 28.9, which means an acceptable value for this would be something between 28.8 and 28.9. However, to estimate one place past the point of measure, that means you need an extra decimal place because there's an actual line for 28.8 and an actual line for 28.9. That's the point of measure. One place past that would mean 2 decimal places. That last place is your estimation, so it could be anywhere from like 28.80 to 28.90 if we're going to say it's between the lines. Here I think it looks like it's pretty much halfway between, so I would call this reading 28.85. So again, my point in this is not that it's a different volume. All of these are the same actual value. It's just the number of significant figures in the way that we express it. Since we already did this together as a class, I'm going to skip down to the reading graduated cylinders here so that we can look at more examples. So if you are reading a graduated cylinder and I'm looking at this one where it goes 1, 2, 3, the numbers get bigger as I go up, so this is the opposite of what we just did. So my 0 would be at the bottom, so I read from the 0 to the bottom of the meniscus. The bottom of my meniscus of my water line is like here. This one's not as curved as the other one. So always orient yourself and figure out what the lines mean. So between 2 and 3, halfway between 2 and 3 is what? What is halfway between 2 and 3? 2.5. And then as you get closer to 2, so we're going down, this next line would be 2.4, 2.3, 2.2, and 2.1. So this one to me looks like it's exactly on the 2.3 line. However, because the 2.3 line is our actual point of measure that's actually marked on here, I need to estimate one place past that. And if I think it's exactly on that line, instead of writing 2.3, what would I actually need to write? So this one would have 2 decimal places as well, 2.30. So each of these were marked the same. So C and A up here had the same number of markings, meaning every 1/10 of a milliliter was marked. So you would need to estimate to every 100th of a milliliter, one place past that. That's not always going to be the case. So if I jump to example A right here, it's 5, 10, 15, 20, 25, 30, 35, 40. So it's going up, meaning our 0 is at the bottom. Measuring from the 0 to the bottom of the meniscus would put us like here. So I need to figure out what that line actually represents. So if I zoom in, let's see. So halfway between, or actually, no, not halfway. This one, halfway between 35 and 40, is going to give us kind of a weird number. So we're just going to try to figure out what the markings are. If this is 35, the next one would be 36, 37, 38, 39, 40. That matches up with the lines that are marked. So what line is this one closest to? Where's my water level? Are we on the line for 35? Are we on the line for 36?
37.
We're like pretty much right on the line for 37. But because 37 is the point of measure, that's the actual line that's marked, we are always going to estimate one place past the point of measure. So if 37 is actually marked, to show the next point of measure, or estimating one place past that, I would need to add a point something. So if you think it's like 37.0 because it's exactly on the line, that's perfect. So in this case, if you answered 37 milliliters versus 37.0 milliliters, I'm saying that even though those two are the exact same value and the volume present in each of those is identical, they have different numbers of significant figures. So I would not give you credit for 37. You would need to say 37.0 to tell me the level of precision that your graduated cylinder showed.